What's going on, everybody, and welcome back. Today we're going to take a brief break from Siemens PLCs and we're going to take a look at Mitsubishi PLCs, more so working with Mitsubishi GxWorks 2. We're going to learn how to create a brand new project in GxWorks 2, set up our communications, write a small program using contacts, coils and even timers, and then we're going to compile our project, download that to a PLC, a Mitsubishi FX PLC that I've got behind me there, and we're going to test it out and see how this works live. Now, if you guys don't know this about me already, I'm 27 years old and I've been working with PLCs since I was 15 years old, and the very first PLC that I was taught on was Mitsubishi, and what I used to program that PLC was GxDeveloper. Today we're going to be able to look at some of the newer software that's out there using GxWorks 2. Now, just a brief history about Mitsubishi PLCs. Back in the early 90s, before Windows 95, Mitsubishi used what we call Medoc, which was a DOS-based system to program its PLCs. And then after Medoc was GxDeveloper, and that there was Mitsubishi's first platform on a Windows system. After GxDeveloper came GxIEC Developer, and that there was to adhere to the new IEC standards that were starting to be pushed out into the industry. Following from GxIEC Developer, we then had GxWorks 2, which we're going to have a look at today, and then you've got GxWorks 3, which is the newest software out today. However, that only programs certain PLCs, looking at the I-Series and the R-Series PLCs, as well as the FX5 PLCs. Today we're going to be working with a Mitsubishi FX2N PLC, and for that we're going to need GxWorks 2. Now, if you guys do hear any background noise, that there is from our fan that we have in the training room currently. It's about 27-28 degrees outside at the moment, and for a guy up north, that there is hot and I am sweating. So please forgive me for any sort of background noise there if you can hear that. Now, before we get started, what I'd like you to do to help us out is hit the like button, comment below, just comment anything. You can comment hello or what you would like to see on our next video. Just comment something just so I know that you're watching. And then also, if you're watching us on YouTube, hit that subscribe button so you stay up to date with all sorts of Scantime videos. Right, let's get started, guys. So on my desktop at the moment, what I've got here is I've got GxWorks 2. If we just open up GxWorks 2, and what you'll see is a blank project become available. Now, what we're going to do here is we're going to go to project and we're going to select new project. Now, the first thing it's going to ask us to do is to set up the series of the PLC. Now, because we're working with a Mitsubishi FX2N PLC, what I want to do here is make sure that I've got the series selected as FX CPU. If you do drop down this menu, you will see several other types of Mitsubishi PLCs available, but as we're working with the FX, we're going to select FX CPU. And then once we've selected the series, then what we want to do is just drop down our type menu and then select our PLC from this drop down list. As I mentioned, if you're working with the FX5 series, you will be using GxWorks 3. So looking down this list, there's my FX2N, 2NC. I'll just select OK to that. And then the next thing it's going to ask us to do is to select the project type. Now, the first thing you've got here is simple project, and then we've also got structured project. What we'll do, guys, is we'll have a look at simple project first and just see exactly what a simple project is inside of GxWorks 2. The language we're going to leave as ladder and not use SFC. Just say OK to that, and then what we should see is our simple project open up here. Don't show this message again, and then just say yes to that. Now, if anybody's ever used GxDeveloper, you'll probably recognize this very quickly. This effectively is GxDeveloper in a new shell. It's using the whole GxWorks 2 branding, but it's effectively a GxDeveloper project. This is what they mean by a simple project. Again, you have your components exactly the same way as you did inside of GxDeveloper, and your programming area is also exactly the same way as it was inside of GxDeveloper. If I want to add a contact in here, I give it the address X0, for example. I tie that to a coil, and I tie that to Y0. That there is our GxDeveloper. Hit F4, and it should compile my project. GxDeveloper, guys. What we're going to do here, though, is we're going to work with a structured project. And a structured project is what's new with GxWorks 2. A structured project allows us to create what we call POUs and function blocks and functions, very similar to what we use inside of Siemens. And it more so works alongside the whole IEC standards. So what we're going to do here is we're going to go back to project, go back to new, FX CPU, FX2N, and we're going to change the project type to a structured project. select OK to that, and you'll see now you've got structured ladder and FBD. You've also got structured text and instruction list. We're going to stick with ladder here, and then we're just going to say OK to that. I'm not going to bother saving that project. And here we go. This right here is your new structured project inside of GxWorks 2. You don't get this sort of design inside of GX Developer. Now what you'll notice straight off the bat is we no longer have a main program. What we have now is a POU, and a POU stands for Programmable Organization Unit, and this is where we write our main program inside of. This is where we structure our program, similar to OBs inside of Siemens. And then we also have a folder for FBs, your function blocks, and your functions as well, like I say, to go alongside that IEC standard. Now what we're going to do first of all is we're going to set up the communications for this project. We're currently connected to this FX2N PLC behind me via its SC09 lead, and it comes to our laptop as a USB. Now to find where that USB is connected to, all we need to do is go to our Start menu, go to the Control Panel, select System, and then go to Device Manager, and then inside of Device Manager, if we scroll down, you'll see Ports. And if you open up ports, there is our USB. If I just disconnect that USB from my laptop, I should see COM5 disappear, which I do. And if I connect that back up again, we should then see COM5 become enabled. That there is our programming comms port for this PLC. So we need to keep that in mind. Let's close down Device Manager, let's close down our control panel, and then what we want to do is we want to go to the communications window. Now to see the communications window, what I'll need to do is I'll just need to remove this bottom banner for now. And at the very bottom here, you will see our communications window. It looks like a PC with sort of like a green line around it. If we just select OK on that, you'll then see your current connections pop up here. If we open up all connections, connection 1, here is our transfer setup. And again, if you've used GX Developer, it's pretty much an exact copy of GX Developer. Now what we're going to do here is we're going to set this up for COM5. You can see it's already set up there as COM5, but we'll show you how to do it again. Just double click Serial USB, and then where we have RS232C, there's your COM port, and there it is, COM5. And you've got a whole selection here of different COM ports we can use. Make sure it's using the one that we've selected, which is COM5. You can also set the transmission speed from here as well. And you can see here that this one here is set up to 19.2 kilobaud. Now you can set this all the way up to 115 kilobaud, I believe it is. However, this PLC here is restricted to 19.2 kilobaud. Anything higher than that, and possibly the PLC wouldn't be able to communicate with that. Just select 19.2, select OK, and then what we want to do from here is nothing else but do a connection test. Select connection test, and then it should come back and then say successfully connected with the FX2N, FX2NC CPU. That there tells us we now have a link between our laptop and our PLC behind me. Let's just say OK to that, and let's just say OK to that. To go back to our project tree, next to our communications window and next to the user library is our project window. If I just click on that icon there, it then opens up our project library, and that there is where we can access all of the blocks and also the tags inside of our program. Now what I'm going to do is I'm just going to bring my ticker back. There we go. And now what we're going to do is we're going to set up our program in terms of setting up its tags. Now when we set up tags, or what Mitsubishi call labels, this just allows us to write our program easier instead of us having to constantly refer to the addressing x0, x1, x2, y0, y1, y2, etc. Now what we're going to do here is we're going to set up our global tags. Now our global tags tend to be used for X's, which are our inputs, Y's, which are our outputs, M's, which are our internal bits, and then D's, which are our internal registers. Anything else like our symbolic addressing tends to be used inside of our local labels. Open up global labels, and then you'll see there global 1, open that up. Don't display this message again, and here is our global label settings. And what we can now do is we can now address all of our inputs and all of our outputs from this PLC into our global labels, giving them some sort of symbolic name that would mean something to us, like start push button, stop push button, lamp, etc. So what I'm going to do here is I'm going to drop down our class and I'm going to select the class as var global. I'm not going to select var global constant, that there is for a value. And for the label name, what I'm going to do is I'm going to call the very first label start PB for start push button. It's then going to ask you for a data type. Just click the 3 dots and then select bit, because it's just going to be an on-off signal. And then what it's going to do is it's going to ask us for the device, and that there is the Mitsubishi address. So we're going to select X0, and X0 is our very first input on our PLC. And you'll notice next to that device is another column labeled address, and you'll actually see in there the percentage sign IX0. That there is your IEC addressing. And I spoke a little bit about this last week in terms of system function blocks with Siemens, and this is all to do with the IEC standard. And this allows us to write a program inside of Mitsubishi, and we can actually move this to another PLC, and it will use this IEC addressing and not the actual Mitsubishi addressing to convert the program across. Now what we're going to do is we're going to create another global, and we're going to call this one stop PB for our project. And again, this is going to be a bit, and we're going to use X1 this time, and this is going to be our next input. So this is how we can actually set up input addressing inside of our PLC. Next, what we'll do is we'll create some output addressing. So another var global, and we'll just call this one lamp1, and we'll just create this as a bit again, and this one will be Y0. And if we just select OK to there, you can see now the addressing is QX0. I's and Q's are your IEC inputs and outputs. And then we'll just create another var global as well, and we'll just create this as lamp2 bit Y1. And what we would do in an actual project is we would go through all of the PLC inputs and outputs that are going to be wired, and we'll create the actual global addressing for this from here. Now what you can also do, which is just jumping ahead, is we actually create CSV files for this addressing. You'll notice up here we've got read from CSV and write to CSV. What we can do is we can export all of this addressing to a CSV file. Say yes to that, and we can just call this global1 inside of our documents. And then if we go to our documents folder, inside of there is our global1 CSV file, and that will contain all of the addressing for this project. That then could be accessed by anybody else on another laptop which doesn't have GxWorks 2 on it, and they can alter the addressing should they see fit. They could then send back a revised version, and then all we would do is we would then read from that CSV file and import that in, and then it would reflect inside of our GxWorks 2 project. That's pretty neat and handy. Now what we're going to do as well is we're going to create some mbit addressing, and we're going to use this mbit addressing to actually toggle our program. We're not going to use the actual inputs here because I've got no push buttons wired. I'm going to use mbits, and I'm just going to toggle the mbits from inside of the program. So again, just go to var global, and then what we'll do is we'll call this start pb m, and we'll leave this as a bit, and this will be assigned to m0, and then again we'll just create another one, and this will be stop PBM, and this will be a bit, and again we'll tie this to M1. So we'll actually use these two inside of the program instead of using the physical input addressing, as we don't have any push buttons to press here. Now once our global labels are set up, we can actually get into our program and start writing the program. To do this, open up your POU1 folder, go to program, and then inside of here you'll already have your very first network created, and we can resize this by dragging it up and down. And what we're going to do now is we're going to create a standard start-stop latch using the components that Mitsubishi give us. So the first thing we're going to do is click on the open contact, which is just up here. Select the open contact, or you can actually select number 1 and it'll also create an open contact for you as well. And you'll notice we can drag this anywhere we want in this network here. It's not like Mitsubishi GX Developer or Siemens TIA Portal or Step 7 where you click your contact and it inserts into the network in a fixed position. You can add this anywhere. Now this could be a good thing and a bad thing. A good thing because it gives you flexibility, but also a bad thing if you don't have any sort of OCD, because what you could then do effectively is you could place your start-stop latch any which way you want it to, and you can make it look any which way you want, and this here would still work just like a start-stop latch would. And if I add in our latching bit here, I can then connect that up to there, and that effectively is a start-stop latch, but obviously that's not how you would want to design it. So you got to be a bit more strict with yourself in terms of how you are designing your program, because like I say, because it's completely flexible, you can design this any which way you want. So what I'm going to do here is I'm going to delete this from the program, and we're going to create the start-stop latch properly and with some sort of structure. So what we're going to do is we're going to click on the normally open contact, or just press 1, and there's our normally open contact, and I'm just going to place this inside of the network here. I'm then going to get my normally closed contact, number 2, and I'm going to add this shortly after it, trying to keep the spacing somewhat the same, like so. And then I'm going to get my output coil, and I'll place my output coil over here. Again, just keeping everything in line, keeping it all uniform. What I'll then do is I'll get another input, another normally open contact, and I'll tie that just underneath the first normally open contact, keeping it in line. I don't want it over here, it just doesn't look right. I want it in line, so it keeps everything looking nice. And then what I want to do is I want to branch up to this rung here from this rung. To do this, you'll notice when I hover my mouse over this node on the right hand side of the contact, it changes to a pencil. What I want to do here is I just want to click once. And when you click once, you then create this line. And then all you need to do after this is just move this line to wherever you want to place it, and then click once again. So what I'll do here is I'll just click once here, and then that there will tie it to the top rung. So again, it's a little bit more flexible than what we're used to using inside of Siemens or anything like that, but you do have to be a bit more strict with yourself when you're designing the program. Personally, I'm not a fan of designing programs this way, because like I say, it becomes a little bit messy later on when you start designing many networks, and networks differ in size. You start to have coils in line here, then coils over here, depending on the size of the network, and then you have to go back through and move everything across to keep everything in line. But to each their own, I don't prefer it myself. Now what I want to do next is I then want to assign these contacts and coils to addressing, and to do that, click on the very first normally open contact where the question mark is, and we'll just type in start, and as we start doing that, you can start to see all of the global labels pop up here. And remember, I don't want the start PB because that's actually wired to the input. I want the start PBM, which is the M bit. Select that. And there we go, and you'll see it turn pink. When it turns pink, that there tells you it's assigned as a label. And if you hover over that label, you'll then see M0 pop up. That there tells you the address that you're wiring that to. Go to the next one and then select stop PBM. And then that there creates our M1. Now what I want to do is I want to latch on a lamp, and I'll latch on lamp 1 and create my latching bit. Here, lamp 1. So everybody knows how to create a latch, or they should do by now, the amount of times we've designed them in different sorts of programmers. We have our start PB as a normally open contact, our stop PB as a normally close, going to our lamp coil. When our start PB closes, current will flow to our lamp. The lamp contact will then energize, creating current flow across the start PB, meaning we can let go of the start PB and still have the lamp energized from itself. The only way to then reset the lamp is to then trigger our stop PB, which opens the contact, resets the latch. Next, what I want to do is I'm just going to resize this network, and I'm going to create a new network. Add new ladder block after. What I'm going to do here is I'm going to tie this lamp 1 to a timer. Now, to get our timers, all we can do is we can select our element selection window icon from the top toolbar here, which is number 8. It looks like a little microchip. Select that, and out pops our element selection, or just our instructions window if you ever used Siemens before. And what we want to do is we want to open up our function blocks folder. And inside of your function blocks folder is where all of our timers, counters, rising pulses, falling pulse triggers are all located. So you can see here, there's our CTU, there's our CTD and our CTUD. And we also have our TON, our TOF, and our TP. These are what we were using inside of our Siemens TIA portal, and also our Siemens Step 7 professional system function blocks, if you've seen that from our last video. These here are the IEC function blocks. Now you'll notice next to some of these instructions are _E identifiers. These _E identifiers refer to enabled signals. So what this means is if I drag in, let's say, a TONE, and then just say close to that, I'll come on to that later, it has an enable and an enable output signal, while the TON doesn't. Okay, so what we can do here is we can enable this timer and then control it when the input signal turns on. So it'll only run when the enable signal is on and the input signal is on. This timer will only run when the input signal is on. So this one doesn't require an enable signal. So what I'll do is I'll just delete that, and I'm going to go through that again. Now we're going to use just the standard TON timer, exactly what we've been using on TIA Portal and Siemens Step 7 system function blocks. To do this, just drag and drop in your TON timer. And when you do this, it's going to ask you to assign this timer to a register. And this register is very similar to a data block inside a Siemens, an instance data block. And you'll see here, it's asking you to give it a name, and we can give it any name we want. So I could call this, for example, Chris Timer, and it's saying where do you want to register it, and you can see here it's assigning it to its local label inside a POU1. That there is this section here, not inside of the global labels. Global labels can be accessed from any part of the program, while local labels can only be accessed from the block it's a part of. So we're just going to leave it as a local label. The class is going to be a var, which is a variable, and the data type is going to be our TON data block effectively. What I then want to do is I then want to select apply and then close. And you'll see just above my timer now is Chris Timer in pink, meaning that it has been assigned to a label. And if we open up my local label folder, there is the timer. And that there is effectively the instance data block for that timer. So when this timer runs in our program, it stores all of its data in this section here in our local labels. Now with this being a local label, if I created another POU, let's say I created a POU2, I could then use the name Chris Timer again, because that there is another local label in another block. It's its own entity, so it doesn't fall under duplication, because Chris Timer in this block is part of POU1, whilst Chris Timer in POU2 is a part of POU2. It's separated. If I used it in my global labels, however, I could only use that label once. Otherwise it's duplication, because global labels can be accessed from anywhere in the program. Let's go back to my POU. And when you have your POU, you can see there we have our input, our PT, our Q, and our ET, just like we do inside a Siemens. Now what I want to do here is I want to tie this input to my lamp condition. To do this, again, all we need to do is just hover along this node until you see the pencil icon, click once, move to the contact, and then click again. And that there ties our lamp contact up to this timer. Next, I want to give this timer a time value, and I'm going to run this for 10 seconds. And just like in Siemens TIA or Siemens Step 7 system function blocks, all we do is we type in T#10S. And that there is the identifier for time inside of an IEC timer. Our Q is our output coil, and we'll tie this to our next output coil, which is our lamp 2. And then finally we've got our ET, and the ET is the elapsed time. Now you don't necessarily have to have the ET, and if you don't want to use the ET, just select the horizontal line and then select delete. And what that does there is it removes that ET from that timer, and it will download it to the PLC without it. That's fine. Now if I want to monitor how long this timer has been running for, I need to give this a variable. Now I've already deleted the variable, so to add a variable back to it, next to our element selection window is our var inputs and our var outputs, number 9 and number 0 on our keyboard. If I select our var outputs number 0, this there allows me to then select on ET and create a tag for that. Now what I'm going to tie this to is I'm going to tie this to a local label. I'm not going to use this in my main program, I'm just going to use this inside of the block just so I can see how long this timer has been running for. So for me to create this as a local label, I can just give this any name. So I can call this Chris elapsed time and then press enter. And what will then ask me to do is again assign this to a register inside of our local labels register. If I want to assign it to my globals, all I do is I just drop this down, I select global, but I want to assign this to the local label because it's only going to be used inside of POU1 only. Select local label, leave it as a var, which is an internal register to this block, and then you can see there the data type is labeled as time. Select apply to that, and then close that down. And now we have our Chris elapsed time label. And if we just go back to our POU1 local labels, there is our Chris elapsed time, and there is our Chris timer. Once again, if I created another POU, I could then create these tags again within that POU's local label. If I create this inside of the global, however, it can only be used once. Let's go back to the program. So here I've got my program created, and it's simply just a start-stop latch controlling a timer. After 10 seconds, the timer will then turn on lamp 2. When the timer loses its signal, the timer will reset just like it does in any other PLC. Now, if you look on the left-hand side where my project tree is, you'll see that some of the folders and files are indicated as red. This tells me that these haven't been compiled yet. Now, to compile a project, you can go to the compile menu at the top and then select build, or you can go and do rebuild all. Build will simply just build this block only, whilst rebuild all rebuilds everything inside of the project. Now, because I've got several areas labeled as red, that there tells me that my project needs a rebuild. So you can press Shift Alt F4, or you can just select rebuild all. Select rebuild all, select yes to that, and it then should pop up at the bottom with an output window, and it should tell us that we got 0 errors, 0 warnings, and 0 check warnings. I can then just close that down there, and you'll now see that on the left hand side everything is black, telling me that everything's been accepted in my project. Next, just save my project, and I'm just going to call this Chris Test. Say save to that. And then what I'm going to do is I'm going to download this to the PLC. So select online and then select write to PLC. Next it's going to ask you what do you want to download to the PLC. So what I'm going to do first of all is I'm going to select program. And what that'll do is it'll highlight the main program, and you'll see there that it pops up at the bottom, program size 63 steps. Now if you're not aware, a step inside of a program is a contact or coil, and you might be saying, well, hang on Chris, we've only got 1, 2, 3, 4, 5 contacts and coils and 1 timer. How the heck is there 63 steps? Well, that's because inside of this timer function block is more ladder logic, and that's what makes up the other steps in this program. So you can see here we've got 63 steps in use out of 8,000 steps for my PLC. Next, what we could do is we could then download the PLC parameters. Now, because we haven't changed any of the PLC parameters, which is in the top left hand side of my project tree, I'm not going to download the project parameters. If we did make any changes to the parameters, we would then have to check that box and then download that. And then what we can then download is our global device comments. And the device comments are things like start PBM, stop PBM, lamp 1, lamp 2. All of those are comments. The problem is if I select that and tell that to download to the PLC, it'll come up with a warning message saying there's not enough memory in the PLC. And this is because this is an old FX PLC and it doesn't know how to handle comments inside of its program well without taking up a whole bunch of memory inside of the PLC. So what we tend to do is we tend to leave that unchecked. It means if we ever do an upload from this PLC, we're going to have no comments, just the addressing. And we're going to leave device memory unchecked as well, because again, this is just a blank project. Everything's going to be set to 0. There are no device memory settings that we've uploaded or anything like that, so we're just going to leave this unchecked too. Next, what we want to do is then select execute. It'll then say that the PLC is then going to be switched to stop mode. Are you sure you want to do this? Say yes to that. And it's going to begin writing to the PLC. Now, once this is finished writing to the PLC, what it'll then ask us to do is to switch the PLC back to run mode. And there we go. So now it's asking us the CPU status is currently in stop. Do you want to switch it back to remote run? Yes, I do, Mitsubishi. And now what we can do is we can then select close, close, and we're ready to go live. To go live and to monitor our program, we have two ways we can do this. One way is to select this icon here, which is to start monitoring. And what this allows us to do is to monitor this window only. However, if I want to monitor everything in my project, I would then just select start monitoring all windows. And by a force of habit, I always just select start monitoring all windows. So select there, start monitoring all windows. Say yes to that. And we should then see our PLC go live. And you can see here that our normally closed contact has this blue square inside of it. That tells us that it's currently closed. Everything else has these white squares inside of it. That there tells us that they are currently off or open. We then have our timer down here, and you can see the current elapsed time is T#0 milliseconds. So what I want to do is I want to run this project, and to do this, what I'm going to do is right click my start PB and select modify value. Inside of our modify value, you then see our start PBM, and you'll then be given the option to switch it on or switch it off. And what I'm going to do here is switch it on. When I select this as on, it's then going to turn on the lamp. Our lamp will then latch on, so I can then switch this off again, and the lamp will remain on, and then our timer will begin running. After 10 seconds, our timer then turns on lamp 2. So 3, 2, 1, switch it on, switch it off, and there we go. Our latch is currently enabled, our lamp 1 is currently on, our timer is now currently running. 10 seconds later, our lamp 2 now turns on. If I then select my stop PB and then select that as on, it then resets my latch and then resets my timer back to 0. If I then trigger the start once again, it'll begin counting once again. If I stop this at any point, the timer will then reset back to 0, just like it does with any other PLC. Just close that down there. And that there is creating a very basic program inside of Mitsubishi GxWorks 2. So what we've done there is we've created a brand new project, we've set up communications, we've then created some local labels for our hardware addressing and our internal addressing, like our M bits. And then what we've done is we went inside of our very first POU and we've created a program. We've created a program using contacts and coils, as well as the IEC function block TON. And we've also created local labels for the timer and the elapsed time for that timer as well inside the POU1. We've then compiled it, downloaded it to the PLC, and then tested it out by modifying the actual M bits there. And that there is a brief introduction to Mitsubishi GxWorks 2. As I mentioned, there are some downsides to it. I'm personally not a fan of the flexible ladder logic design. I prefer it being more fixed like it is in Siemens, but there are some positives to it as well. It is a very simple and easy to understand programmer just to get straight into and learn with. And like I say, this was the very first PLC that I was taught on. It wasn't GxWorks 2, it was GX Developer, which in my opinion is even more easier than GxWorks 2, but it still is a very easy to work with, easy to understand programmer. Not as complex as some other programmers that are out there. I hope you guys have enjoyed the video. Once again, just give the video a like if you haven't already done so. Comment on what you'd like to see next week. And if you're watching us on YouTube, don't forget to hit the subscribe button so you can stay up to date with every new video that we put out. Thanks for watching, guys, and I look forward to seeing you again next week. Have a good one.